everybody, another day and another SolidWorks software training. In this training, I want to show you how we can run the tensile test analysis in software. And for doing this analysis, we must design our sample. As you see, I designed a strip uh, sample and this is the dimension of my sample. You can design your appropriate sample. For example, I design a strip and you can design a round bar sample for your analysis. I exit sketch. The important issue for designing this sample is you must split the surface to three sections because I want to apply the boundary condition and force in these two surfaces. Okay, after designing your sample, you must choose your appropriate material. I determine my appropriate material in my sample, and I want to show you how we can do it. Click on material and click edit material. You can go to custom materials folder and click on new category. After the creation of new category, you can click on new material. After clicking new material, the table of your material appear here. As you see, I choose for model type the plasticity 1 Meister, and my units is megapascal and category is plastic. You can choose your appropriate name for your material. For example, I change to X70 and the description I remained X70 also. The default failure criterion is 1 Meister stress. As you know, the elastic modules of metals is 2E11 and the Poisson ratio is 0.3. Tensile strength and yield strength is up to your material that I extract of this graph. This is the result of stress strain of tensile test, and according to this graph I extract the tensile and yield stress, and also in the next step I use the result of this graph for entering the stress strain parameter. Okay, after input these data, you must go to create a stress strain curve. As you see, the table of strain stress will appear here, and you must input your parameter. If you want added the new columns under this row, new rows under this row, you just double click here and another rows will appear here. I input my parameter before, and as you see, this is my stress strain curve. This is my tensile and this is my maximum strain. As you see, is 0.1. After clicking apply, we go back to the SolidWorks environment. I want to explain the important issue to you. You must pay attention the point number 1. This point must start with the yield point of your sample. As you see, My yield points is 483, and also this is 483. You couldn't choose 0 483 because the yield stress is the first point of our plastic zone. Okay, click apply and go to nonlinear environment. I want to delete this analysis and run another analysis. Okay, and now we must go to the simulation environment of SolidWorks software. If you couldn't see this tag, you must go to SolidWorks add icons and click on SolidWorks simulation and choose SolidWorks simulation premium. Okay, if you couldn't see this tag, now we click on new study. We can choose our appropriate name and click on nonlinear and dynamic analysis. As you see, the window of nonlinear dynamic analysis will appear here. As you see, the material of our sample determined before, and also we must choose the boundary condition. We must determine the boundary condition and apply transformation in the direction of X campus. Okay, uh, we don't have any connections in this sample. For boundary condition, we must fix these two surfaces and click OK, and then we must apply a transmission on these two surfaces in the direction of X. We can write 12 millimeter transition in the direction of X, because the maximum strain of our sample was 0.1. Know this sample, know this stress strain curve. The strain stress curve of our material that I determined in the before step. We can choose on flat surface, and the direction of surface is the direction of transmission is very important. In direction of X, you can by clicking here reverse this direction, and also active the transmission in the direction of Z and in the direction of Y, but we must write zero transmission for these two directions. Click OK, and then we go to create mesh and click on mesh parameter and choose curvature, because we have fillet on this sample, and click OK. We can right click and go to properties. For saving time, we can decrease the increments of this analysis, for example by choosing fixed, and if you want the exact result, you can choose automatic increment type and then click OK, and now we can run our analysis. After 28% of progress, the result appear here. As you see, the yield strength of material is 483 megapascal, and this unit is Pascal, Newton per meter square. As you know, megapascal is Newton per millimeter square. We must stay to complete the analysis, and we can see the result of this analysis. Okay, our analysis has been seriously has been ended now, and we can see the result of our tensile test. And for example, the bone masses results, as you see appear here. You can see the necking phenomena. As you see, the fracture will be appear here for better interpret the fracture area. As you see, here is necking area, and after necking we have fracture. As you see, the final fracture will be appear and will occur of this area. Now I want tell you about some common error in this analysis. If you saw any error in the result of your analysis, you must check the for example determine material because the choosing method of analysis is very important. I stay to opening the custom material window to show you, for example, this model type plasticity bone masses is very important. You must choose this type, and then you must determine the appropriate boundary condition and appropriate displacement. For example, this axial millimeter, this axial displacement should be in relation to this maximum strength. For example, the maximum strength we determine is 0.1, that's mean 10 millimeter, and we must exactly determine the 10 millimeter for this displacement. I determined the 13 millimeter axial displacement, and after 74% of running the progress of result, the error has been appear in my window, and the interpret of that error was you couldn't determine the axial displacement more than the maximum strain. I hope you enjoy of this training, and I hope you could use the result of this analysis in your designing. Thank you so much.